defective shells we have from each supplier. Of those 200, the sample of the 200, shipment 1 has 6 defectives, 6 out of 200. Shipment 2 has 26. Shipment 3, supplier 3, so this is supplier 1, 2, and 3. Supplier 3 has 22 defectives. Which supplier do we like the best, just based on that? Yeah, we like supplier 1, shipment 1. And we like supplier 3, or supplier 2 the least. Alright, now why, just based on that data, are we not quite ready to fire supplier 2 and double or triple our shipment from supplier 1? Why are we not ready to do that just yet?
Not confident yet.
We're not confident yet, right? Because this is just what? Sample. We want to know, can we be confident that this sample truly reflects the whole population? So we have a couple ways to do that. We could do confidence intervals for a proportion, but let's do something more fun. Let's do the chi-squared test for proportion differences. Okay? Let's do it. So let's get our observed frequencies with all the possible outcomes, defective, not defective. Alright, those are the only possible outcomes here. Supplier 1, supplier 2, supplier 3. This is from the case, or from the problem. 6 defective, 26 defective, 22 defective. And the other possible outcome then out of 200 would be 194, 174, 178. Null hypothesis. What is our null hypothesis in this case? Can someone read that null hypothesis to me? Yeah, and instead of saying 1, 2, and 3, can you give me another term? The true population?
Of all.
The shipment?
Okay, which shipment?
Shipment 1.
Okay. Shipment 1, supplier 1, true population proportion of defectives of supplier 1 equals the true population proportion of defectives supplier 2 equals true population of defectives supplier 3. Remember I said, I just threw out there, maybe these suppliers give us 20,000 cell phone shells, and we just looked at a sample of 200. So they're all the same in our null hypothesis. Now do we have some evidence to the contrary? Some evidence that that may not be true?
Yes.
We do. Question is it overwhelming? And if it is overwhelming, we're going to say not all population proportions from these suppliers are the same. And say we'll use a 5% significance level. That's what we consider overwhelming evidence. If we have something that is less likely than 5% given this assumption, then we're going to reject this. All right. So, expected frequencies, what do I have here? Yeah, I want the full table of expected and observed, and then I want the chi-square calculations. Okay, so can someone read off the observed here?
6, 26,
24, 22?
182,
Okay, how about here?
194,
194,
174,
174,
178.
178?
Yes.
All right. Okay, and then what is the expected frequency in shipment 1 of defectives?
18.
Expected frequency of shipment 2 defectives?
18.
Yes. So we take column total, 54 of the total cell phone shells we found were defective, out of a total of 600. So 54 out of 600, that's like 9%, right?
Yes.
All right, so we take 9% times 200, and we get 18 for all of these. All right, how about non-defectives? Same thing here. What percentage out of the total were non-defective? Multiply that by the total in that shipment. What do we get for shipment 1 non-defective expected frequency? If the null hypothesis is true.
91.
I don't know if I like 91.
I don't know if I did that.
180.
182.
182.
Yeah, I forgot to go.
Yes. 2, okay? Good. Good, now we have observed and expected. Are our observed frequencies different than our expected frequencies? Yeah, so our next step is to quantify that somehow. And say, how big is that difference? Is it a highly unusual difference? So, let's start working on the chi-square test statistic for each one. How about you all on this half? Why don't you do these three? You all on this half, do these three. You all on this side of the room, why don't you do these three?
Times 200, the total.
Just to total on that?
The one row, the row
And that's what we got.
The 18. And then when you do 9, you do 546, so multiply 600, then times 200. And 182. Yeah, 182.
Alright, so whatever the total is just the total of that row, the output. Okay, I did that one.
For
Okay, now, we're going to do the same thing.
No, which one?
That would be the 6.
Okay, it's non-defective you do it. I did the defective.
Anyone? What do you got, Tang?
Squared.
Defective.
Which box were we doing?
You tell me, you just pick one.
Oh, the
Wait,
defective.
one second, please. Go ahead, Tang. Whichever one you want. I never mind. Alright, who has go ahead.
The defective one.
You did, which one? Top one?
Yes, 6, take away 18, I got negative 12.6666.
I don't like negative numbers.
Well, I think it's not, it's,
Which one is that one?
no, the 6 take away 18.
Upper top right?
Upper top right, what do you got?
I think defective is 12.
Excuse me, that's not.
No, the defective one is 12.66.
That's what I'm.
The defective one is 12.66.
Alright, 12.66, you got
The
that?
bottom one number is 3.555, no, the second shipment is 3.555, and just keep going.
5, alright,
And the next one is point.
Alright, Ron, what do
A few
you
of us
got?
got 8 for the top left one.
Top left, you got
Top
eight?
left, top left.
Yes.
Oh,
Top left, yeah.
Oh wait, this is point, I'm sorry.
That's 1.75.
That's 0.75, and Ron likes 8, what?
That's 8.
We like
8
8.
even?
8
8.
even.
Okay,
And the one to the right that you just did was 1.75.
this one.
Yeah. 0.75. No 0.
What's that?
Say again?
1.75.
1.75. Okay.
That's not right.
Are we using the equation that has the two sum symbols? Okay, so that one that you just put 1.75 is 0.791. You did, cause you have to do 182
Alright.
minus,
Whoever
194.
Whoever calls it last, I guess.
But I'm asking you, we did 194 minus 182 squared, divided by 182. That was the process?
Yes.
Okay, just confirming.
Alright, anyone else got anything?
I did say 0.791
For which one?
for the top one, she doing.
For which one?
The second
This
one
one?
on the right, yeah.
0. What?
3516.
Yeah.
Alright, anyone have this one?
0.0879.
0.0879.
I approve that.
Anyone have this one?
0.88.
0.88.
It's like 8.
8.
Yeah.
0.8.
That one top one is not 8. And that one
No, no,
is
that's correct.
8.
No,
That's
that
The
is.
top
correct.
one
That's
is, I got a different number. 6 take away 18 is negative 12, right?
No, right,
Square root to the,
that's 144 divided by 18.
Yeah, that's right.
Alright, are these all close, roughly?
Yeah.
Okay, what do they all add up to?
20.884.
So our chi-squared test statistic equals 20.884.
Yes.
What's this? 0.879.
20.884. Okay, good.
0.087.
Alright, what is our chi-square critical value?
5.99.
How do we find the chi-square critical value?
You gotta subtract
Row minus 1 plus column minus 1.
If row minus 1 times columns minus 1 is our degrees of freedom, back of the book, what would be highly unusual for that number of rows, that number of columns?
How many we got?
And it's the same as before, it's 5.991. Alright, and our test statistic is 20.884. Alright, what is our decision? We reject. Again, what are we rejecting?
The shipment defective.
No.
That the proportion is all the same.
We reject your shipment.
We're
I refuse order of your shipment. Is that what you're saying?
The true proportion, you said the true proportion of the
You add up
defective
all the
shipment
boxes.
does not equal.
Alright, so what's our null hypothesis one more time? Kelsey, in your own words. Just tell us in English, what is the null hypothesis?
That all the population,
The true proportion of the shipment one's defective items, defective cases is equal to the true proportion of the two defective cases is equal to the true proportion of the shipment case defective.
Okay.
So they're all equal.
put it all
Yeah, I like that.
together.
So the true proportion of defectives are equal in each supplier. What do we think about that statement? That the actual true proportion of defectives of all 3 suppliers are equal. What do we think about that statement?
So now we come.
We're gonna reject that.
We reject that.
Keep on.
I reject that statement. No, it's fake news. No, we've got a little bit more work to do. But what are you thinking about maybe you're gonna do once you run a few more tests and calculations? Besides take lunch and go home. After you get this conclusion, I reject that null hypothesis. What are you gonna do after you do a little bit more work? Survey? But what are you gonna tell your employer who just bought 20,000 shells from supplier 2 and 3?
Return it.
Send it back.
Recall.
Send it back. Let's get more shells from supplier 1 and less from supplier 2 and 3. Yes, Ron?
The critical value seems so extreme as to make it useless, make the test useless.
It's so extreme. Well, this gives our test more power, right? Because this is so different from what we would expect if it were true that all 3 suppliers were the same. Like you told me that all 3 suppliers are the same. If that is true, then I would expect a critical value somewhere in here. Alright, not only did I find something unusual that was passed here, I found something so unusual. The chances of that being true are what? You need to find the p-value, right? You can use Excel to find the p-value. It would tell you the chances of the null hypothesis being true, 0.00000025. Is that right? That makes sense? Okay. Good. Alright, let's do course evaluations, then take a break. So let me I'll do a couple things. I will direct you in logging into Blackboard and seeing where your course evaluations are. And then I'll turn off the tape, don't worry.
Is this for the survey?
Yes, course
I
evaluation.
can't do mine right.
Okay, well, don't tell them yet.
Maybe I did.
Professor, just to clarify, we're supposed to add all this up, and that is our T-stat, right? Why did I get 13?
Alright, so can everyone log into Blackboard, please?
You got 13, right?
Go ahead and log into
I got
Blackboard.
13 too.
It's 13, I did the wrong.
It is 13,
It's
right?
13, it's not 20.
Yeah.
Yeah, it's 13.